To replace an iPhone 14 Pro with a broken display with a new one produces around 65 kg of carbon emissions and uses new materials. If you repair your device, the environmental impact is much lower. Also for other devices and gadgets, repair is often beneficial for the environment because it extends the product lifetime. However, ease of repair, so-called reparability, is in many cases low, and professional repair can be expensive. Therefore, we as product engineers and makers have to ask ourselves, how can we design future products and technologies for reparability and make them more sustainable? In this video, we want to find answers to this question. Hi there, my name is Hendrik from the ETH Feasibility Lab at the Product Development Group Zurich. At ETH Feasibility Lab, we support industry in early-stage engineering challenges. We help with unbiased exploration and rapid testing of solutions to go from uncertainty to proof of concept. Over the last year, our industry partners have increasingly brought up the topics of circular economy and design for repair and disassembly. Originally, we had limited knowledge about these topics, but we wanted to gain capabilities to enable our industry and research partners to build products that are easier to repair and disassemble. Now, we want to share our insights from this recent learning journey with you. So what is repair? One academic definition says, repair is the correction of specific faults in a product, bringing the product back to working condition. In simplified terms, this means first broken, then fixed. When you repair anything, there are always 3 steps. Let me illustrate these with a bike having a flat tire. 1. Disassembly. You open the screw of the wheel, you take it out of the frame, you remove the tire from the wheel and take the tube out. 2. Fixing and exchanging component. In this step, you either repair the tube with a patch or you replace it with a new tube. 3. Reassembly. Here you do everything from disassembly in reverse. To express how easy it is to repair something, there's a term called reparability. With the 3 steps of repair in mind, reparability boils down to how easy is it to 1. Disassemble the device, 2. Fix or exchange the faulty part, and 3. Reassemble the device. Now, let's find out in practice how you can improve the repairability of devices hands-on. Since 2020, there's a European norm on repairability, EN 45554. It contains broad criteria on repairability and will now guide our hands-on demonstration. There are 5 criteria for repairability on a product level. A. Disassembly depth. B. Fasteners and connectors. C. Tools. D. Working environment. And E. Required skill level. Let's start with disassembly depth. Disassembly depth means how many disassembly steps are necessary to repair a crucial, so-called priority part, for example, a smartphone battery. Do I need 20 steps to take out all the smartphone components until I finally reach the battery at the very bottom? Or can I just open the back of my smartphone and quickly access the battery? The latter is definitely more repairable. The smart use of modularity, stacking and packing can significantly reduce your disassembly steps. Our next criterion, B. Fasteners and connectors, also influences the disassembly depth. Fasteners are elements that mechanically join the parts of a device, like screws, clips, rivets or glue. Connectors are elements that establish the electric circuits, for example plugs, sockets or soldered connections. If we design for repairability, we need to implement reusable fasteners and connectors that don't easily break during disassembly. This is especially the case for screws, durable clips and plugs. Not as good for repair are removable fasteners and connectors. They can't be reused and break during disassembly, but can at least be replaced by new ones. Examples are cable ties or adhesive tape. The typical smartphone battery is held in place with strong double-sided tape that needs to be preheated. To put the same or another battery back in, you need to remove the old tape and apply a new piece. The worst type of connection for repair is neither removable nor reusable. To separate such a connection is mostly destructive. An example is the use of strong adhesives. To separate the components, you have to rip them apart, partially destroying them. Another good design for repairability practice is to reduce the variety of fasteners and connectors. This means, for example, using only one type of screw in your design and thereby requiring less tools and sorting of screws during the disassembly. This old Game Boy Advance is a bad example. Nintendo mostly used 3-point screws, but if you open the battery bay, you will find a typical Phillips screw. Of course, it also makes repair easier to reduce the total number of fasteners. This decreases the necessary steps for disassembly and therefore also decreases disassembly depth. 10 screws are still bearable, but 50 screws in one small device can be annoying. And finally, a higher visibility of connections helps. Instead of hiding screws under caps, tape or in deep holes, make them more obvious. The third of our 5 repairability criteria is C, tools, and can make repair smooth or annoying. The set of tools you need for repair depends on the type of fasteners, the previous criterion we talked about. Simplified from the EU norm, we can distinguish between 3 different categories of tools: basic tools, commercially available tools, and proprietary tools. The basic tools that are assumed to be available to most people are screwdrivers with different heads, hex keys, combination wrenches, multiple types of pliers, tweezers, a pry bar, steel hammer, utility knife, multimeter, soldering iron, hot glue gun, and magnifying glass. As the next category, there are commercially available tools that don't necessarily come with a typical toolbox you can get at your department store. An example for such tools is a Torx bit with a hole inside, like this one. This special Torx is often used as a kind of security screw that is not meant to be opened. And eventually there are proprietary tools, which aren't publicly available to the market, or for which a fair patent licensing doesn't exist. It's difficult to open fasteners that need a proprietary tool, which is a big obstacle to repair. An infamous example for proprietary tools and screws comes from Apple, the pentalobe screw introduced in 2009. At that time, it was impossible to find a repair kit with a pentalobe bit. Another example from my childhood are so-called line head screws from Nintendo's Game Boy cartridges. Criterion D looks at working environment necessary for repair. When you can repair a device in its environment of use, for example, your laptop in your office or your dishwasher at home in your kitchen, this is considered lower effort than sending your device away. For some products and parts, for example, for fixing the pistons of your car engine, you need a dedicated workshop environment. If your product needs to go back to a production environment, this is the most specialized repair environment. Our last repairability criterion E is the required skill level. Your product design determines if a layperson, a generalist, an expert, the manufacturer, or no one can repair the product. Let me quickly recap the learnings from this video. Repair consists of 3 steps. 1. Disassembling the device. 2. Fixing or exchanging the faulty part. And 3. Reassembling the device. The 5 criteria for improving repairability are A. Disassembly depth, B. Fasteners and connectors, C. Tools, D. Working environment, and E. Required skill level. So what's next? Go further. Take the impulses from this video and transfer them to your product, device, or context. Go deeper. Check out the content and references in the description below and sharpen your own understanding. And finally, come back to us. Let us know what you liked about this video and in which areas you would like to know more. Thanks for watching and please dare to repair.